All right, so in 4.5, we're going to be graphing sine and cosine. So the graph of sine is what we have here. Starts at 0, goes up to 1, goes back down to 0, down to -1, and back to 0. So from here to here is just one period of our graph. So if we look at our unit circle, we can kind of compare it to going around the unit circle, which would be like one cycle around. Sine is y. So here, sine is 0, then sine goes to 1, then back to 0, then back to -1. So it's kind of a graph of the unit circle a little bit. So that would be one cycle or one period of our graph. Cosine, remember cosine is x. So looking at the x in our unit circle, cosine starts at 1, then goes to 0, then -1, then back to 0. So cosine graph starts up at 1, goes down to 0, -1, 0, +1 again. So this is our cosine graph. They have the same shape. The only difference is they start at different places. Cosine starts up at 1, sine starts at 0. The domain of our sine and cosine functions is a set of all real numbers. That's because our graph continues to go forever like this. It's kind of a bad shape, but it goes forever in the left and right directions. The range is the interval from -1 to 1. So if we look at our graphs on the last page, they go up to 1 and down to -1. So that would be our range. The range can change depending on the amplitude, which we'll look at in the next couple of slides where we're given transformations on our sine and cosine functions. So again, here we have our graphs of sine and cosine. The difference is their starting points. So sine starts at the origin, cosine starts at the amplitude. Right, and the amplitude in just our basic graph is 1, because it's whatever gets multiplied out front. So in just our basic graph, our amplitude is going to be 1, but you'll see in other functions when we have transformations happening to it, how the amplitude changes. It's on the next couple of slides. So here's our basic characteristics of it. So example 1, we have to sketch the graph. G of x is equal to 2 sine x by hand on the interval from -pi to 4pi. So whatever gets multiplied out front, that's our amplitude. So here we go up to 2 and down to -2. So it's really, like, it doesn't change much, it just changes the intervals that you go up and down to. Our intervals on the x-axis, when it's just our basic graph and we have no transformations, it's the same intervals that we have on our unit circle. So like in degrees, it would be 90, 180, 270, 360. But here, we always have to put it in radians. So this would be pi over 2. Then we would have pi, 3 pi over 2, and 2 pi. I'm going to change the interval here just from 0 to 2 pi, just because I ran out of room. But we could keep going in our intervals. Every interval goes a half pi, adding a half pi, half pi, half pi. The intervals always should be in radians. And then because this is a sine graph, do we start at the amplitude or start at 0? Start at 0. So we start at 0, then go up to our amplitude, back down to 0, down to our negative amplitude, then back to 0. So think about it as you can only move like one space at a time. A common mistake is that people will like skip 0 and just go from the positive amplitude to the negative amplitude. So you can only move one space away. This would be one cycle on this interval, but we can keep going. So this would be negative pi over 2 here, and we would go down. So like continue it, and it just continues that same shape. Okay, so here's the fun part. So we are going to have more than just sine to graph. It can be multiplied by a number. We can have x being multiplied by a number. We can have a number added to x and a number added to the whole thing. So this is our a, b, c, and d. A is the amplitude, so that is our range. A is always positive, so we think about the positive A. If there is a negative, we have a reflection, but the reflection is actually like the easiest part. It's always going to be the last thing that you do. You just flip your graph upside down after you graph it. So think about A as always positive. Your amplitude is positive. B is the next thing that comes. That determines your time period. So our time period is 2 pi over b. So that is like how far we go. So 1 cycle is our time period. So this would be 1 cycle. C is our phase shift, so we would move left or right. C over b is our starting point. So if we move our graph to the left, we're no longer starting at 0 for our sine function. We start at whatever our starting point is.
Is it the same rule that applies for the graph shifts that we did a while ago, where if it's negative, you move to the right, and if it's positive, you move to the left?
Yeah, because it's minus c.
So this phase shift affects the x-axis,
Right. Left or right. So the x-axis. And then D, whatever we're adding on the outside, is a vertical shift, so we go up or down.
To the amplitude?
If our graph, so our graph starts here, our basic graph, and goes this way, D would just shift it, so instead of starting at 0, we would start it here, but it still continues that same shape and goes like that. It keeps the same shape.
So not only the amplitude, but all the other points?
Yeah.
Okay.
So I'm going to do A. Since our amplitude is 1/2, I'm going up to 1/2, down to negative 1/2. Does cosine start at 0 or start at the amplitude?
Yeah.
Starts at the amplitude. And then where do we go next?
0.
To 0, and then down to the negative amplitude, back to 0, and then up here. And then our intervals, since nothing is happening to our intervals stay the same as like the 90, 180, 270. So it would be pi over 2. Here we would have pi. Here we would have 3 pi over 2. And this would be 2 pi. Oh, and I need to draw it. So that's our cosine graph.
Why does that look?
It's just one section of it. So cosine, since it starts up here and then goes down and then ends there, it's kind of like you can't really see the curve, but if we continued it, it would like continue the curve that way.
Yeah. Okay.
Sine, you can kind of see more of the curve because it like starts at 0. So it's just a different perspective of it, I guess. For B, the only difference is that the amplitude changes. So instead of going up to 1/2, this would be 3, and this would be negative 3.
Oh, okay.
So the only difference is the amplitude changes for B.
So,
Okay, so if we have a negative amplitude, if we're multiplying by a negative out front, all we do is flip our graph upside down. So we would start with the red one, the positive, do everything we need, and then we just flip it upside down at the end. And let's say that this is pi over 2 here. I don't know what happened to it. Okay, so the first thing we want to do is identify our A, B, C, and D. And then to help us graph, we need our starting point, which looking here, our starting point, C over B. We also need our period, which is 2 pi over b, and our increment, which is the period over 4. So these are the 3 things that you really need to identify before you start graphing. And then just identifying what A, B, C, and D are will help you plug in here. So it helps that A, B, C, and D go in order. So A, B, C, D. So A would be what? 1/2. B is 1. C. So C is what we're adding inside the parentheses. But since C is a minus C, we always change the sign of this, so it would just be pi over 2. And then what would D be? Are we adding anything after? Nothing, so 0.
What's C?
Pi over 2. All right, so let's find our starting point first. We have C over B, so that would be pi over 2 over 1, which would just be pi over 2. So on my graph, I'm starting at pi over 2. What's my amplitude? How high up and how far down am I going to go? 1/2. Next, I need to find the period. 2 pi over b. So 2 pi over 1, which would just be 2 pi. Finding the period helps us find our increments. So we just divide the period by 4. So 2 pi over 4, which would be pi over 2. So all my key points are moving at an increment of pi over 2. So the next tick mark there would be plus pi over 2. Then plus pi over 2, plus pi over 2, plus pi over 2. You have to add it 4 times because we need 5 key points.
Is it just kind of like a baseline, or?
Yeah. Because you always have your starting point, and then you'll have 4 more points after that. And that'll give you that one whole period of it. So that's one cycle.
One full cycle.
So we have pi over 2 plus pi over 2, which would be pi. Then pi plus pi over 2,
3 pi over 2.
3 pi over 2. 3 pi over 2 plus pi over 2, 2 pi. And 2 pi plus pi over 2, 5 pi over 2. Awesome. So I think the most common mistakes that, or I guess what people struggle with the most from teaching this last year was coming up with the increments. Which all you have to do is just add the increment 4 times. All right, so now this is a sine graph. So do I start at 0 or start at the amplitude? Sine starts at 0. But I have to start at my starting point, which is pi over 2. But I'm starting at 0 on the y-axis. And then sine, do I go up or down? Sine goes up. Then I go back to 0, down to my negative amplitude, then back to 0. And then I just connect the dots.
How do you get your starting point?
Starting point is C over B. So I want to find my A, B, C, D. Starting point. Period. And increment. And starting point is C over B. Period is 2 pi over B. And increment is period over 4. So A is 3. The negative just means that we have a reflection. So at the end, we have to remember to flip our graph. So we're going to save that for the last thing that we do. I'm going to put my graph here. My amplitude is 3. So I'm going to go up to 3, down to negative 3. What is B?
2.
B is 2. C?
Negative pi over 4.
Awesome. Negative pi over 4 because you have to flip the sign. So it would be negative pi over 4. And D? 0.
Why did you put positive 2 for A?
All right, so let's find our starting point. That is C over B. So C is negative pi over 4. And B is 2. So keep, change, flip. This would be negative pi over 8. So we are starting at negative pi over 8. So I'm starting in the negative direction here. This will be pi over 8, negative pi over 8. That's where I start. Now the period is 2 pi over b. So 2 pi over, what's our b? 2. It's 2 pi over 2, which is pi. All right, last let's find our increment. So our period was pi, so pi over 4. So for each increment that I go, I'm adding pi over 4. So plus pi over 4.
I thought it was 2.
No, your increment can change. And we have,
Another increment that's on the negative side.
well, let's find out if we do. Because what's negative pi over 8 plus pi over 4? We got to add it. So negative pi over 8 plus pi over 4 would be, make this 2 pi over 8. So pi over 8. So it's on the positive side.
But like, could you have another increment?
You could possibly have one, yeah.
But would that mean that you have to make like an extra increment on the positive side to make up for the one on the negative side?
No, you just need 4 increments after your starting point. So then again, I need to add another pi over 4. So pi over 8 plus pi over 4 would be, make this 2 pi over 8. So what would that be? 3 pi over 8. Add another pi over 4. 5 pi over 8. Okay, and then 5 pi over 8 plus pi over 4 would be 7 pi over 8. So those are increments. So you just keep adding pi over 4 to get each one. And then this is a cosine graph. So cosine, do we start at 0 or start at the amplitude? We start up at the amplitude. Then where do I go?
Down to 0.
Down to 0. And then
Down.
down to negative 3.
And 0 again.
Back to 0. Up to the positive amplitude. So this would be my graph.
So should we don't go to 0, 0?
You don't have to. No. So you don't have to go to 0, 0. You just go to where your increments are. So your increments is what your key points will fall on. This one is negative. So we have to flip. So everything that's above the x-axis is now going to go below. So our first point's going to start there. We go to 0, go up to our positive amplitude, back to 0, and there. So our graph actually looks like this. So because it's negative, we just had to flip all of our points. So we can erase the pink one because the pink one is just there to show us what our regular cosine graph would look like. But the black one is our actual cosine graph. So you just take what you had and flip it upside down.